Assalamualaikum warahmatullahi wabarakatuh and every good day to everybody. So now we are moved to a new course we have done static, because in our program you are taking diploma. So we did in static, we didn't learn the whole content of the static. We only study the 7th chapter of the static. Now we are moved to a new subject, a new course, but in the same subject, because we are combining the subject static in dynamics. In dynamics, we also didn't learn the whole content of dynamics, but we only focus on your study on the first beginning 4 chapter in the referring to the engineering mechanic dynamics written by the R.C. Hibbeler. Okay, so now we are moved to new first chapter. First chapter, basically I want to make it easier in our course. This chapter, although this first chapter from dynamics, but it's actually 8 chapter. You already learned from the beginning of the semester until now. This chapter number 8 we have learned from the beginning. Okay, so now we are focused on kinematics. This one's in the beginning of the dynamics. We are focused on kinematics. So the objective, hopefully by today or in and also the first half of this video, we are focused. We a student. You should be able to determine the kinematic quantities such as position, displacement, velocity, and acceleration of particle traveling along a straight path. Okay, so before we go further, so I just want to make an overview. Just want to recap what we have learned in mechanics, static, the early beginning of the chapter last time. In mechanics, actually the study on how bodies react to the force acting on them. So we are study on the body, how they react to the force acting on them. So from this one we have a two area, statics, dynamics. So whereby the static is a study of the bodies in equilibrium, but the dynamics we have two parts, kinematic and kinetics. Kinematic only concerned about the geometric aspect of motion, how you want to describe the motion. So kinetics is concerned with the force causing the motion. So kinematic, we just find the velocity, but the kinetics, how the motor, how the car move with a certain that particular velocity. So different between kinematic and kinetics. So now we are focused on the kinematics. So the in rectilinear kinematics mean by the continuous motion. So for example, a particle travel along a straight line path defined by the coordinate axis S. This one's coordinate axis S, for example. So it travel from point O to point P. So the position of the particle at any instant relative to origin point O here is defined by the positive scalar R, positive vector R, or the scalar S. S is magnitude. So R is a position vector R. So scalar S can be positive or negative. Typically units for R and S is a meter or feet for imperial units. So the displacement of the particle is defined by when the position is moved, change the position, another position. For example, the point P change to P prime. So the vector form is the displacement is the delta R is equal R prime minus R, whereby the in scalar forms the delta S, S prime minus S. So total distance traveled by the particle, St, is a positive scalar that represents the total length of the path over which the particle travel. Okay. So when the objects move from point O to point P with a certain time, so it's actually we can measure the velocity. What is velocity? So velocity is a measure of the rate of change in the position of particle. It's a vector quantity which has both magnitude and a direction. So the magnitude of the velocity is called speed, which is the unit of meter per second. So the average velocity of the particle during the time interval delta t is equal to delta r dividing by delta t. So the instantaneous velocity is the time relative to position v is equal to dr dt. So we want to find at that certain time of that certain position, so that's called instantaneous velocity. So speed given by the v is equal to ds over dt. So average speed is the total distance traveled divided by elapsed time. So here is the average speed, so total distance divided by total time. Okay, so what will be the acceleration? So if the object moving with a certain velocity, then it's a move another change, the velocity change, another will be higher or lower the previous one, the previous velocity. So and then when the changing have a certain time or certain period, so acceleration is the rate of change in the velocity of particle. It is a velocity quantity, it's a vector quantity, sorry. So the typical units are meter per second square for the SI units. So instantaneous, again, instantaneous acceleration is the time derivative of velocity. So in vector form, A, instantaneous acceleration is a dv over dt, and scalar form, so A is a dv dt. So v here is meant for the speed, this one is a vector in terms of the direction. So acceleration can be a positive or negative. If the positive speed increasing, so there is a negative speed decreasing. Okay, the relative equation for velocity and acceleration can be noted to get E ds equal to v dv. Okay, we just want to make a summary of this kinematic relation. So if you want to differentiate, so velocity is equal to differentiate the change of the distance, change of displacement over change of time, ds over dt. A is a dv over dt, and A is equal to v dv ds. So integrate, if you differentiate the position, you get the velocity. If you differentiate the velocity, you get the acceleration. But if you integrate back the acceleration, you get the velocity. If you integrate the velocity, you get the position. So that here s naught and v naught, s naught and v naught, they represent the initial position and velocity of the particle at t equal to 0. Okay. So what is meant by the constant acceleration? So now for the three kinematic equation, so what is the three kinematic equation? So this one, all this kinematic equation here, so it can be integrated for a special case when the acceleration is constant. So we put our assumption acceleration is constant to get very useful equation. So a common example of constant acceleration is gravity. So body freely falling towards the earth, in that case the g is equal to 9.81 meter per second square downward. So the this equation, from using these three equations, so integrating dv, integrating ds, integrating v dv, so what we get, we yield the three useful equations. V is equal to v naught plus acceleration constant t, or and also s equal to s naught plus v naught t plus half e concentration t square, and finally v square is equal to v naught square plus 2e concentration constant acceleration equal to multiplied by s minus s naught. So we can see example here, a particle travel along a straight line to the right with a velocity v is equal to 40 minus 3t square meter per second, where t is in second, also s equals 0 when t equals 0. So now we want to get the position acceleration of the particle when t is equal to 4 seconds. So it's very important, what we want to plan to do is we make our positive coordinate, establish the reference plane x and y. So in the project is given in positive coordinates, since the velocity is given as a function of time, take a derivative is to calculate the acceleration. Conversely, integrate the velocity function to calculate the position. So meaning that we have the v function of time. So if you are differentiate respect to time, you get the expression. But if you integrate the v respect to t, you also can get the position. Okay. So we take the derivative of velocity to determine the acceleration. A is a dv dt. So v is a 40 minus dt square. So 40 minus dt square, differentiate respect to t, where we get 4 minus 6t. So a is equal to, you just substitute the t when t equal to 4 seconds. So when t is equal to 4 seconds, You just substitute 4 minus 6 multiplied by t. It's multiplied by 4, so you get minus 20 meter per second square, or in the direction to the left when t to the 4 second. So distance, calculate the distance, so you just integrate the 4t minus t square. Since the velocity, you're integrating the velocity, you get the distance. So what you get here, 2t square minus t cube, you just substitute 4 seconds into the equation. What you get, minus 32. So s is equal to minus 32, meaning to the left. Okay, I think we stop here, and then we are move for a new topic after this later, inshallah. See you again in next time, in next video.